Sentiment analysis has become a very popular big data application in the recent years. Consider, for example, the hundreds of millions of tweets every day. As a result, organizations can listen to the voice of their consumers like never before. Manufacturers of consumer goods, from electronics to food products, are able to measure the popularity of their brands versus those of their competitors by simply counting the number of positive versus the number of negative comments that they find on forums like Twitter, Facebook, emails, wherever. They even convert the voice that they listen to in a call center to text, and then measure the number of positive sentiment versus the negative ones. Well, most often the sentiment is negative because people don't talk too many positive things about brands, but when they do, that means the brand is probably very positive. So you can build that bias in. But this has become an extremely popular application in the big data world, and let's see how it works using Bayesian machine learning. Think about a few comments that all of you might have been posting on the forum. Well, I haven't used real comments. I made this up, obviously. There aren't that many comments on the forum. I wish there were. Be that as it may, think about comments like this. It's a positive comment. There may be lots of these, but there may be some which are very negative, and so on and so forth. Suppose we were able to manually label comments as being positive or negative. In this, obviously, we use human intuition and not some automated technique. This is called the training phase. After that, could we figure out using naive Bayes whether a new comment is positive or negative? Let's see how to do that. First, we need to compute the a priori probabilities, that is the overall chance that a comment is positive, which is simply the number of positive comments divided by the total number of comments, which is 8,000 in this case, 6,000 of them being positive. And similarly, the probability of a comment being negative a priori, which is the number of negative comments divided by the total. And then we need to compute the likelihoods. For example, the probability that the word like occurs within the positive comments. So of the 6,000 positive comments, like occurs in only 2,000 of them. So we get this likelihood. Similarly, the probability that enjoy occurs amongst the positive comments can be computed similarly. Now notice that there are no comments which are positive but include the word hate. We can't put 0 for this because that would make the formula go completely out of whack. So we replace those by a low number like 1. This is called smoothing in the naive Bayes classifier, and this is very important because we have to include all likelihood probabilities. Now we do the same thing for the negative comments. The probability that hate occurs amongst the negative comments is 800 out of the 2,000 negative comments because this comment contains hate. The probability that bore occurs is 0.1. Like occurs, again by smoothing, is 1 over 2,000, and so on. Note also that the probability that enjoy, which might be thought of as a positive comment, amongst the negative comments is not that small. And we'll come to this phenomena later. The reason is that the enjoy is occurring along with a negative term. Similarly with lot. For the moment, we need to factor in all the likelihood probabilities simply by looking at the words and their occurrences, and we'll worry about things like not next week, or rather the week afterwards. We're only going to consider the words marked bold, and for these words the likelihood probabilities look like this. So we can compute the probability that like occurs amongst all the positive comments, easy, and so on, and simply the same thing is done for the negative comments. You can work this out for yourself. It's a good exercise to do. Now faced with a new tweet, say I really like this simple course a lot, something we haven't seen before, we can compute the likelihood ratio, which is simply the probability of like occurring, because like happens to occur in this tweet, given that it's positive, and everything in the numerator is given that it's positive. And for hate, which does not occur, we compute the probability that hate does not occur, given that the sentiment is positive, by taking 1 minus the likelihood ratio. Clearly the hate can be there or not there, so if it's not there, the probability of not hate given positive is 1 minus the probability of hate given positive. We include every possible word amongst the bold words that we have considered, and even those which don't occur in this tweet, we include their probabilities by taking 1 minus. Lastly, we multiply by the a priori probability. Similarly for the denominator, and we get a likelihood ratio of 0.026 over a very small number, 0.00005, which is very much larger than 1, so the system can easily label this tweet as being positive without ever having seen it before. This is an example of the machine having learned to identify which tweets are positive and which are negative based on historical data using the naive Bayes classifier.